Hello, welcome. Sorry about the small technical delay at the start here. My name is Clinton Perry. It is my honour to be your host today at the Birmingham Technology Centre here in the UK. So over the course of the next 30 minutes, I hope to inspire you and show you lots of leading emerging technology that we think Autodesk is bringing to the marketplace to allow people like you to fundamentally change the way we design and make the world around us. So over the course of the 30 days, we'll be talking about the technology that you can see here. And I hope that at the end of the time, you will feel so inspired that you want to come and visit this technology centre yourself, or even connect with Autodesk and start a conversation about how we can work with you to make a difference to your business. So we are today in the technology centre here in Birmingham. This is one of a network of technology centres that we have around the world, and they all focus on different things, different pieces of technology. It could be generative design, it could be artificial intelligence, cloud-based computing, design, manufacturing, additive hybrid manufacturing, and so much more. Here in this technology center, we focus on advanced manufacturing solutions. And as you will see, as we start through the tour, we have a range of different machines that allow us to provide technology to you for additive manufacturing, CNC machining, generative design, and much, much more. Okay, so to the side of me, we actually have a really great example of one of our customer components. This is a single-seater sports car by a British company called Briggs Automotive Companies, BAC. And we'll be talking about components from this car and how Autodesk technology has allowed the designers to make faster, greener, cleaner, more engaging single-seater sports vehicles. So we're going to talk about the car throughout today's tour. But the first thing we'll talk about is this rather impressive array of robots that we have behind me. And we want to talk a little bit about different types of technology that the world of manufacturing is embracing and using to fundamentally make new things, make anything, and make the new possible. So what we have here is two KUKA robots. These robots have multiple moving components, and on the end of each robot, we have a tool. And robots are a very flexible platform. We can use these robots to do additive processes, subtractive processes. We can put tools on the end of the robot, like chainsaws, hot wires, pens. We can use this very, very flexible manufacturing platform to allow manufacturers like you to make amazing parts in a wide range of different ways. Now, today you can see that the robot on the left is actually running an additive manufacturing process in a polymer to produce components for the architecture, engineering, and construction sector. I can't tell you about the customer, but what's really cool here is how rapidly these robots can be producing components that can go on a construction site. And the great thing about these robots is that they can be driven individually, or they can work collaboratively. So one robot can be holding a workpiece whilst another robot carries out processes on it. So they're a very, very flexible platform and something that Autodesk sees being used increasingly in the world of manufacturing. So we're going to move into a different area of the tour now. So if you'd like to follow me through. So this is the Technology Centre proper, and it's divided into lots of different sections. On the right, you see we have a bank of CNC milling machines. These are the workhorses of the world of manufacturing. And we have a variety of different types, different sizes, different values. This one that's closest to me is an extremely expensive, accurate CNC machine that's used to make parts for jet engines or cars or medical implants. Very, very flexible, accurate manufacturing platform. And if we head to the left here, we have a number of amazing customer stories that I'd like to talk to you about. And the first one is a project we worked on a few years ago for the Port of Rotterdam for a company called Ramlab. Now you can see the image on the right here is actually a large ship's propeller. And this is a world's first. This is the world's first additively manufactured and accredited, approved ship's propeller. First one in the world, and Autodesk was proud to be involved in this project. So why have we been involved in this project? Well, you can imagine there are millions and millions of tons worth of stock cargo being shipped around the world right now. And those ships rely on components like the propeller to keep the world's products moving around. And if a ship has a problem where a propeller breaks and it needs to be repaired, then these ships are effectively dragged into a dock, and then the damaged propeller is removed from the boat, and then they have to wait weeks, months for a replacement propeller to be installed. And during that time, the ship is not making money for that company. So it's very wasteful. So the RamLab organization decided they wanted to embrace emerging technologies to change this problem. And so they are able to manufacture propellers on demand, meaning that they no longer have to have factories full of spare parts or warehouses full of spare parts. So it saved huge amounts of time and money, allowing these propellers to be replaced in a matter of weeks instead of maybe many months. And if we just take a quick look at the actual equipment that was used to produce this propeller, you can see it's very simple. It's another robot fitted with an arc welding tool on the end. And then our software, Fusion 360 in this case, is used to move this equipment around and deposit material very rapidly to produce 3D printed components, such as the components that you can see on the table here. These are very rough test pieces, but we use this same technology to produce this 400 kilogram ship's propeller in a copper beryllium nickel alloy. Let's move on to a different area of the Technology Center. And we're going to talk about this rather impressive customer story. And I'm tired, so I'm just going to have a little sit down here. I hope you don't mind. I'm an old man. I need to rest my legs. So this is a project that Autodesk worked with Manchester University. And the project explored the use of generative design technology to allow designers to make more efficient and rather wacky street furniture. So if you look around the back of the bench, you can actually see that the entire structure has been produced using our generative design technology. Now, generative design technology uses artificial intelligence and then a number of parameters that we as designers define. It could be the weight that the bench has got to support. It could be the type of manufacturing that we want to use to make the part. In this case, we're using casting. It can also be the size of the component, whereabouts the component needs to be fixed to the floor, how many of these components we want to manufacture in a given time scale. The key thing here is that I define these parameters and then use generative design to create the 3D shape. No human being has created this shape. It is completely produced by artificial intelligence. And then once that 3D design is produced, we fabricated this using multiple cast components that are assembled together. And then you can see we have the finished bench. So this is a fantastic example of emerging technology like generative design, artificial intelligence, that is truly helping designers to make amazing parts, but more clean, green, and effective components too. Let's move on to the next part of the tour. Now, this is always risky for me, walking backwards. I'm an old man, I could fall over, so hopefully we won't have that. So if we continue on the tour, you can see to the left here, we have a number of CNC machines, as we mentioned before. Autodesk has a variety of different types of machines, and we use different machines to reflect our customers. So we have customers with this kind of machine, which is a 3-axis CNC milling machine, or indeed the one we walked past a moment ago, which is a big 5-axis milling machine. There are thousands of those in the world. Now, we use these machines to manufacture really quite impressive components. And I'd like to talk about two today, very, very quickly. The first one here is an example of hybrid manufacturing. So hybrid is where we combine additive, metal-based 3D printing and subtractive CNC machining. And if you look very closely, you can see that this is an Inconel Blisk, an aerospace component. Normally, these parts will be made from a solid piece of very expensive, very difficult to process material. It takes time, it's expensive. Using hybrid manufacturing, we're able to make these parts much faster, saving thousands of dollars worth of money, but also many hours of processing time and making parts that are cleaner, greener, better for the world. The second component I'd like to talk about very quickly is the one that we have here. Now, this is a component, it's just an aluminium bracket from the construction sector. But what I do want to talk about is this, which is actually a fixture that has been designed using generative design technology to help with the manufacturing of the metal part. So while this is the finished component for the customer, they've had to fabricate this tool to help them make that part. And this again has been designed using generative design and artificial intelligence within Autodesk's Fusion 360 software. Just like before, we have to define things like the fixing points where the component will be held to it during the machining process, fixing points where the fixture will be held to the machine that does the cutting, loads, materials, in this case, we're using polymer-based 3D printing, and then generative design is able to create this component for us and allow us to explore designs that we would never have been able to achieve before, because it's combining the power of artificial intelligence with the ingenuity of the human brain. Now, if we continue to walk down through the rest of the facility, you can see again on the left-hand side here, yet more examples of the different machinery that we have here at the Autodesk Technology Center. What I'm going to do now is talk about two very different projects. Again, still very much focused on generative design. And those are going to be the examples we have here. These are wheels from the automotive sector. Now, both of these wheels have been created using generative design, but it might not be very obvious that that is the case here. The first wheel on the left-hand side is actually a wheel that we designed and produced for the Volkswagen Group. Now, the Volkswagen Group were exploring the use of emerging technology to fundamentally change the way they design and make electric vehicles. Electric cars are becoming increasingly common. We're all looking to buy electric cars, but they have a problem, and that is that electric cars have big batteries that are very heavy. So there is pressure on the industry to make the rest of the car lighter. And this is where generative design helps. This is actually a wheel from a 1962 microbus. I think you may be familiar with the Combi bus, the Volkswagen classic bus there. And we use generative design and CNC machining, again, with Autodesk software, in this technology center to machine this wheel from a solid piece of aluminium. Now, the wheel itself is 18% lighter than the best wheel that Volkswagen could design today. So that's a huge weight saving, which equates to extended range on the electric vehicle. Now, the next wheel is the same problem. We're looking to find a way to reduce the weight in the wheel. And this is for the BAC Mono sports car that we saw in reception earlier on. Generative design has been used again here, but the difference is that the design has been constrained to preserve the brand that the BAC Mono engineers used in the original design. So if we were to compare this wheel with the wheel that they've designed before, you would see no difference. They are identical to look at. But the generative design technology has allowed us to reduce the weight of this wheel by 35%. The original wheel was 3.4 kilograms. These are 2.2 kilograms in weight. They are extremely lightweight. I mean, I'm not a strong guy, and yet I can pick these up really, really easily. And we are able to achieve this purely because of the generative design technology that we've been talking about today. Oh, okay. Oh, right. We've got a little bit more time than I thought, which is fantastic. Let's carry on. Okay, so there's a few other areas of the tour that we're going to focus on now. And the one that I'd like to talk about next is this one behind me. Now, if you look very carefully, what we have here is a series of 3D printed brackets for the architecture, engineering, and construction sector. Now, this is actually a project that Autodesk worked with a customer of ours called Dura Vermeer. Now, these are actually brackets that hold glazing panels onto the sides of buildings. So you can imagine these are the glass panels on the building, and these are the brackets that hold them to the main metalwork of the building itself. Now, these brackets are traditionally designed to resist the weight and the pressures that the world's weather will apply onto the brackets when the building is constructed. So each bracket that they design is optimized to resist the maximum wind force that that building will experience during its life. But there's a problem here, and that is that the pressure that this bracket will have to resist differs depending on the floor that we're putting these brackets on. So at the ground floor, the wind forces are very low. On the top floor, the wind pressures are very high. The challenge here is that the Dura Vermeer engineers don't want to use the same bracket design for every single floor, because that means that they waste material and waste money for all of those brackets. So here, we've used the same generative design technology to optimize the design of the bracket based on which floor the bracket will be used, allowing us to save time, save material. And whilst you might not think weight matters in a construction site, it absolutely does, because these brackets have to be lifted up on a crane, and the crane uses energy to do that construction process. So making these brackets lighter saves the planet, it saves money, it saves emissions. It's a greener, cleaner solution. Okay, let's carry on. There's one more customer project I'd like to talk about in this area, and I'm going to turn around so I don't fall over. Now, in this particular section, we've got a range of very large CNC milling machines, and the one over to the right here is a great example of a 5-axis CNC machine tool from a company called Hermle. Now, we use that particular machine to manufacture this component. Now, get ready for the surprise. If I pull the sheet back, you can actually see that this is a titanium blisk from the aerospace sector. This is the sort of thing that you would see at the front of a jet engine on an aircraft that we all use, or hopefully we will use soon when we're able to fly and go on holiday. Now, the story here is this is a component that the customer approached Autodesk and said they had a goal to reduce the time it takes to manufacture these parts. Currently, it takes 200 hours to make this part, 200 hours. And they had a mission to reduce that down to 135 hours. If they achieve that, they can meet the production demands to keep putting aircraft engines onto jet engines or onto aircraft. So they worked with Autodesk, and we were able to achieve that goal. We modernized their manufacturing process. We used the machine that we just talked about with modern cutting tools, and we were able to get to 135 hours. But we weren't finished there. We realized that we could embrace even more innovative technology using really impressive CNC machining processes to reduce this machining time down to 35 hours. So we went from 200 to 35 hours. That's a 92% reduction in the time taken to manufacture these parts. And we happen to also save on the consumable costs of making this part by 95%. So we were able to make better parts, make them faster, make them greener, cleaner, and at a lower price point. Needless to say, this customer is very, very happy and embracing this technology on a broader range of components. Okay, so we're going to head back now and finish off in a slightly quieter part of the Technology Centre and talk about more amazing customer stories. But as we do, I just thought we'd stick our head into one new department we've not really talked about yet, and that is here, our quality control department. So far today, we've talked about amazing manufacturing processes that we use to make phenomenal components, parts for jet engines, parts for cars, human implants, you name it, we make some stunning components here. But it's essential that we also have the ability to measure those components to validate that they are fit for purpose, they're accurate, that they are ready to be sent to the end customer for them to use. And so in this room, we have a variety of different machines that we can use to qualify that these components are good. On the left, we have a machine that uses structured light on the end of a robot to measure components incredibly quickly, capturing millions of points of data within seconds. Really precise, very, very accurate, and very rapid. Whereas on the right-hand side, you can see a more traditional coordinate measuring machine that is used to do more simplistic measurements, measuring the size of a hole or the width of a slot. The key thing is that these two pieces of equipment are used together to validate that what we make here and what our customers make are good, fit for purpose. Okay, so we're going to move now into the final part of this tour, which is what we call our makerspace. And if you follow me through, for a start, it's quieter, which is great, because hopefully you can now hear my voice a little bit easier. But if you take a moment to look around this makerspace, you can see it has a variety of different pieces of machinery. Now, the makerspace is an area, a safe area, where our staff and our customers are invited to come and explore technology. Explore things like CNC milling machines, explore additive manufacturing through power-to-bed printing equipment, maybe even explore the industrial robots that we were talking about earlier on. We also have a variety of hobbyist desktop 3D printers that we use here to actually fabricate things like fixtures and other tools that we use in the facility to make our customers' components. And on the subject of customers, I just want to finish off this tour talking about one last customer story. This here is another component off of the BAC Mono sports car. In fact, this is an actual production component of the actual car. And it's part of the rear wheel assembly. Effectively, the wheel is attached to it, and then the suspension struts are attached to this as well. So it's a very important part of the car assembly. Now, this component has been fabricated using fairly traditional manufacturing processes. It's actually aluminium. It's been manufactured using CNC machining, and it weighs 1.6 kilograms. So it's a fairly representative component. And if we look carefully, you can see that a human being has designed this and has included pockets to try to reduce the weight. So there has been some design by a human being. But we decided that there was an opportunity to do better. And the new possible for making this part was to use additive manufacturing and generative design to really reduce the weight of this part. So remember, this was 1.6 kilograms. Now, by using generative design, but by changing the method of manufacture to, say, use a 5-axis CNC machine tool, still manufacture the part in aluminium, but really focus on reducing the weight, you can see that our generative design technology is able to create this very different shape. Compare that with the previous design, you can see the key fixing holes are identical, but the outer shape is wildly different. And in fact, this particular component is 20% lighter than the part that's on the actual car. Now think about it. This BAC Mono sports car goes from 0 to 100 kilometers an hour in 2.8 seconds. So if we can reduce the weight of the car by 20%, how much faster would that car go? How much more value is that to the enthusiasts that are capable of buying that car? But what if we apply that same technology to cars that we all drive? General Motors, they're a great example where they're embracing this same technology to make everyday cars lighter and better for us all to have the benefits. So this component was 20% lighter than the original on the car, but it was still CNC machined. What if we change in the generative design algorithms, the method of manufacture, so that we don't use CNC machining, but we use additive manufacturing? In this case, this is metallic powder-bed sintering. So this is a very commonly used method of manufacture. Now you look carefully on the end of the part, you can see that it is hollow with a lattice structure. The lattice allows this part to be a lot lighter. In this case, it's 46% lighter than the original design that we're working on here. 46% lighter. So that's fantastic. What a great improvement that is. But we weren't done there. What if we combine the best bits of generative design with additive manufacturing, but also remove the constraints of a prismatic geometric design? What if we combine the crazy geometry of the blue part with the additive manufacturing of the silver part? And this is what we get. So this is generatively designed specifically for powder bed 3D printing in metallics. The design of the shape, you can see it's very organic. There is no way a human being would be able to come up with this design. It is so radical. Now, this part is actually a solid aluminium piece. You know, if I cut through it, it would be solid. But why don't we use the hollow lattice that we had on this part and apply it to this part? So these two components look identical. There are differences, but you have to look very closely. But crucially, one of them is hollow, and it is 60% lighter, 60% lighter than the original design. And it's only when I hold these two components side by side that I realize just what a difference that has made. And this is all thanks to the generative design technology within Autodesk's design and manufacturing solutions. And as you say, if we look around the center, we can see other examples of generative design in action. This is actually a suspension wishbone component from the motorsport sector. You can see this is CNC machined in aluminium, but it was designed using artificial intelligence and generative design. No human being has designed this. It's been created by artificial intelligence so that it is the optimum weight and the optimum strength for the job that this part is designed to do. This truly is the era of computer-aided design, not just computer drawing tools, but computers aiding us to design and make a better world. So let's finish off. Let's head back out into the reception area. Ooh, bit of a sticky door. So we're reaching the end of our tour. So I'm just going to finish off by saying a huge thank you to you today. Thank you for taking the time for joining us here in the Birmingham Technology Centre. I hope you enjoyed seeing the technologies that we have here. I hope that it has inspired you into thinking about how you can embrace this technology to change the way that you design and make your products so that you too can design and make a better world. Now, I'm not suggesting that you're going to be making these amazing single-seater sports cars, but I'm sure you can see how this technology can be used in your industry sector so that you can make amazing components that are cleaner, greener, and hopefully a little bit more profitable for you and your business. And with that, I think let's take a second to maybe just watch the robots one last time and see what they're doing. I think we're nearly at the end of our time. The chances are the robots are now almost going to sleep themselves.